Right, in this video I'm going to show you how you can plot and get a trend line for some nonlinear data and then work out the equation for the trend line. Now the experiment was to measure the force between two magnets as the separation distance got smaller and smaller. Here's the setup. You can see the two magnets, one on the balance and one in the clamp. There's a close-up. So what we've done here in the scale reading column, the students, this is grade 12 students, put a permanent magnet on an electronic balance and then brought in another permanent magnet from above and then recorded the scale reading as a function of the distance. This video clip shows you how it works. You can see the girl is winding the laboratory jack down and the magnets are coming closer together. So in the first case, here it is here, 0.2 of a metre, which is 20 centimetres. The scale reading came down to 0.1 of a gram and 0.12 of a gram for the second trial. Then they moved it 5 centimetres closer and they got another pair of readings and so on. So as they brought it closer, here we are down at 0.04 of a metre, which is 4 centimetres. The readings are 8 grams or 8.02 grams and 8.10 grams. Now, we've converted each of the scale readings in grams to a force in newtons. Now we've done that by dividing the grams by 1,000 to bring it to kilograms, and then multiplied by 9.8. Done that for both readings and filled down, and then I've calculated the average of the two readings, and that's this column here. Now I'm going to plot the data. So on the horizontal axis, the x-axis, I'm plotting the independent variable, which is the distance, r. On the vertical axis, the y-axis, I'm plotting the dependent variable, which is the force. So we'll select the two columns of data, that one and that one. Now the way Excel works, the first column will be the x column along the bottom, and the second column will be the y column. So I go up and choose a scatter plot, and I get a graph like that. Now that's got the display or the distance apart along the bottom, and it's got the force up the side. Now the next thing to do, I suppose, would be to add a couple of titles here. So this is the force, F, brackets, newtons, and then down the bottom here, the distance, R, in metres. That's all about that. Now, let's add a trend line to this. So I'll select chart elements and trend lines. Now, I don't want a linear trend line. It's obviously not linear. So I'll go and select a power trend line. That'll be here. Okay, so you can see it's chosen a power trend line that fits nicely. So we'll display the equation on the chart and we'll have a look at the r squared value. I'll bring those up there and make them a little bit bigger so you can see them. Okay, now what you'll notice is its y is equal to 8 by 10 to the negative 6x to the power of negative 2.8. Now the negative means it's inverse, and it's about 2.8. So that's somewhere between inverse squared and somewhere between inverse cubed. Okay, so that's the best approximate we've got for the relationship. Now, what we can do with that is to try and linearise it. Now, to linearise that, you'd have to calculate r to the power of negative 2.8. So I've already started that here, and you can see I've got r as by times to the negative 2.76. Well, it should be 2.837. So I'll change that to 837, and we get that value, and I'll just fill down. And so there's my data. Now when I plot the r squared along the bottom, r to the power of negative 2.837 along the bottom, and the average force up the side, it should be linearised. So let's have a look at that. Now the problem is, like I said before, the first column you choose will be the X column. So if we do this, we'll have X, we'll have the force along the bottom and R up the side. Now there's two ways around that. The simplest way for students, I tell them, is to just make a direct copy of this. So copy that and put it after that. Now you want to paste special so that you just get the values. So there it is there. Now it's the same values, except we've got the X along the bottom, which is the first one, and then Y up the side. So now if I plot these two columns, let's see what we get. Insert. Now it'll be something like that. There it is there. I'm going to do a trend line, so I'll just insert a scatter plot without any trend line, and I'll add a trend line now. So let's add a, now I don't want a linear, oh, I want a linear trend line for this, so let's have a look. Linear, but we might add some values. So I'll display the equation and give the R squared. So let's have a look at what we've got. Make that a little bit bigger, say 12 point, so you can see it. Okay, now the y-intercept is very low, 0.011. So the relationship seems to be y is proportional, or y is proportional to 9 by 10 to the negative 6x. And there's a nice straight graph. Now that looks pretty linear. And so what we've done is linearise that data. And that tends to confirm that the relationship between the x and y values is proportional to the inverse of the x value, which is the distance, and the power is negative 2.837. Now another way of doing that is to plot a log-log graph. This is a lot harder for students, but let's have a look at how we do that. Now I've already calculated the log, so I'll just scroll this out of the way so you can see it. Now there's the same data, but what I've done is I've plotted log R, so that's log to base 10 of the R value. Have a look at the equation I've got for that. You can see it's equal to log 10, now that gives me log to base 10, and then A43, which is the R value. So I've done that all the way down, and I've done the same with the forces. I've calculated, you'll see here, log to base 10 of the force, which is F43, that's this cell here. So I've filled those down. Now I'm going to plot those two and we'll see what we get. So I'll select those and insert a graph. Now I'll do this. Now you can see it's pretty linear. Now they're both in the negative quadrant, but you can see that's fairly linear. So what I'll do now is insert a trend line, linear trend line, there it is there, and I'll just get the equation for the graph as well. So I'll display the equation, display the R squared. So here it is here, I'll make it a bit bigger, and home, 12 point, so you can see it. Now you'll notice the slope or the gradient of the trend line is negative 2.837. Now that should ring a bell, because before that was the exponent for the trend line, for the power trend line. So what's happened here is if you plot log, so in other words, this is the log of the distance apart along the, the log of the distance apart is here across the horizontal axis, and the log to base 10 of the force is in the y direction here in the vertical axis. You should get a linear graph, and the gradient is the power of the relationship. So that's done nicely, and you can see the R squared is pretty high, 0.98. That means that equation picks up about 98% of the points that we've plotted. So it's a good fit. That equation is a good fit for the data, we can say. And that's all you need. So you'd report the relationship. As I've said, y is almost an inverse cube relationship. And that's it.